If your sugar levels are high, logic says the solution is just simply to stop eating. And this is a philosophy I see many type 2 diabetics adopt, particularly when the usual things to keep sugar levels in check fail. Does it work? Not as much as one would think. You see, the reason the sugar levels are high is not because you just ate a carb-loaded snack per se. It's a little more nuanced than that. Let's start with what happens when you're not eating. Sugar supplies are low, but you still need fuel. Supporting our giant-sized heads is hard work. The idea is your body reaches into the cookie jars with an S, to keep everyone happy. Of course, everyone is not equal. The boss, that is the brain, gets first dibs on fuel, and the brain is a power user of sugar, hence the need for cookie jars. Now, the jar that is particularly important when it comes to blood sugar levels is the liver. The liver is the chief cook and bottle washer of the body, but his number one priority is to feed the brain. So when sugar supplies drop, he makes a plan. A big part of the plan involves synthesizing sugars from other things. Now, the manufacturing process is called gluconeogenesis, and when it happens in the liver, it's referred to as hepatic gluconeogenesis. The liver is pretty adept at his job. A laundry list of things can be turned into sugar, including certain amino acids, lactate, and glycerol. Now, hepatic gluconeogenesis is the default mode. It's a bit like breathing. If it's not happening, it's tickets. So Mother Nature, in her wisdom, has set things up in such a way as to keep the liver pumping out sugar day and night, unless you're eating. When you eat, the food you eat makes fuel available for everyone. Now, exactly which fuels are found in the food depends on the food type, but if the food contains carbohydrates, you're getting sugar. Some foods supply a trickle, others supply truckloads of the stuff. The point is, the liver's sugar supplies are no longer needed. So on paper, the liver should be able to stand down from sugar-making duties, switch his attention to other things, among them fuel storage. In the insulin resistance, the liver doesn't get the memo. Sugar production continues in full swing, and this is the problem. Body sugar plus food sugar means lots of sugar. Too much for insulin to handle, especially in light of the fact that key players are deliberately ignoring insulin's pleas to take sugar deliveries. So why did the liver not get the memo? Well, the short answer is insulin resistance. The long answer, the fat cells forgot to send the memo. This is what a group of researchers based at Baylor College of Medicine have discovered. Join us for this episode of Better Body Chemistry TV as we find out why your sugar levels can be high even when you haven't eaten anything. Better Body Chemistry TV is brought to you by Dr. Sandy, a scientist turned gremlin buster, helping you battle sugar gremlins, heifer lumps, and other health horribles through better body chemistry. Remember, small things can make a big difference to your health. Asprosin is a new hormone. She was first described in 2016. Her existence only came to light when researchers began studying a genetic condition known as neonatal progeroid syndrome. Folks with this condition have a problem making profibrillin, which means they don't make asprosin. and this impacts their glucose metabolism in a good way, sort of. The team found asprosin is one of the hormones that tells the liver to produce sugar. It turns out asprosin is one of a multitude of adipokines, that is, chemicals produced by fat cells. And in those blessed with lots of fat cells, asprosin levels are elevated since fat cells going about their business pump the stuff out. This in and of itself is not a problem. The problem comes when the fat cells become bolshy and fail to respond to insulin. This means sugar doesn't get taken up by the fat cells. Now, in the big picture of things, fat cells are actually not considered big sugar consumers. After all, they're fat cells. What they do or don't do with the fat is considerably more important. But it turns out the wee amounts of glucose being delivered to the fat cells are important for asprosin. They give her permission to take some time off, which temporarily stops hepatic gluconeogenesis, and this stops those postprandial sugar spikes. The team confirmed the benefits of giving asprosin time off by using a special monoclonal antibody designed to interfere with asprosin's ability to do her job in mice suffering from diet-induced obesity. It helped. When the anti-asprosin antibody was present, glucose levels were stable and insulin levels were significantly lower. So, what does this mean for you? Well, maybe there'll be anti-asprosin therapies, but this will take years to become a reality. In the meantime, this research confirms the battle is not just a battle against sugar, but a battle against insulin resistance. Give your asprosin a little R&R by reining in insulin, so you create better body chemistry and better health. Interested in discovering more ways to create better body chemistry or need a little help getting your body chemistry on track? Visit our website at www.betterbodychemistry.com. Browse our library or enroll in one of our courses or programs. The advice is simple to follow and based on real science, not hype. Know someone struggling with high sugar levels. Share this video with them so they understand the sugar causing the problems is coming from the inside, not just the outside. And if this is your first time here, be sure to subscribe to our channel so you catch future episodes of Better Body Chemistry TV. Thank you so much for watching, and I'll see you next time. Remember, small things can make a big difference to your health.